Hi everyone. So today let's solve the problem number 36, valid Sudoku. So what the question states here, we are given a just give me a second here. Yeah, we are given a this one 9 into 9 Sudoku board, right? So we are given a 9 into 9 Sudoku board that is valid. It is only said to be valid if no duplicate digits in any row. So duplicate digits should not be present in any row. If you know the Sudoku rules, quite obviously that duplicate digits should not be present in any row. And the second condition is no duplicate digits in any column as well. So in the row, in the column also, duplicate digits should not be found, and also no duplicate digits in the 3 into 3 subgrid. So if it is 9 into 9, it will be like this, like right. So just give me a second. So it will be like this basically, right? So here 9 digits will be present in the 3 into 3 grid. This one I'm speaking of. Just give me a second. So just give me a second here. We already have this one here, right? So here this one, this box, so every box will be having the 9 digits, and no duplicate should be present in the 3 into 3 subgrids as well. Subgrids and entire row and entire column, all the rows and all the columns, no duplicate digits should be found. So that's the condition basically to be for the Sudoku to be valid. So again, I'm reading this out loud. So just listen to this. We have to check if the 9 into 9 Sudoku board is valid or not. It is said to be valid if no duplicate digits in any row, if no duplicate digits is found in any column, and if no duplicate digits in any of the 3 into 3 subgrids. We have to ignore the cells with the empty. So that's what they have given here. So this is very important. We have to ignore the cells with this one dot. This dot means empty. So this dot means empty. So that's what they have given here. So I hope this part is completely clear. Question is completely clear. So first, let's discuss the approach by taking the first example along with the complexities, right? So before writing the code, after discussing the complexities and the this one approach and the complexities, then let's write the code. This is simple basically, right? So this is the simpler one. So we have to get the output this one true here in this case, right? So let's see. I'll just explain for the example one. You can just try it out in the same way for the example two. Here in this case, what we will do, just give me a second. Board 0 comma 0, 0 comma 0 means it starts from here, right? 0 0, this is 0 1, this is 0 2, this is 0 3, 0 comma 4 5 6 7 8. So it starts from 0 comma 0. This one will be 1 comma 0, 2 comma 0, this one 3 comma 0, like that. This will be 8 comma 0, right? So same goes with the column here as well. You can just count it on the same way, count it in the same way. So here board 0 comma 0, this one will be having 5. This is having 5 basically. So it is the first 5 in the row 0, column 0, and the box 0. And 0 comma 1, next 3 we have right here. This is also present for the first time. The number 3 is present for the first time in the row 0, column 1, and box 0. And this one board 1 comma 0, this one I'm speaking of, we are having the value 6 here, right? So 6 is present for the first time in the row 1, column 0, and box 0. These are all the things basically. This is valid because it is present in the first time, right? So this is present, and let me delete this one. You can clearly see here 5 is present for the first time, 3 is present for the first time, and 6 is present for the first time in the row, column, as well as subgrid. It is present only once. So let me check this one as well. So just for the understanding purpose, you can just try it. We have to try it for the all the numbers that is present in particular row and particular column, and also in particular subgrid, right? So here let me come to 1 comma 3. This is nothing but the 1 comma 3. So this 1 comma 3 is having the 1 first in the row 1, first time in the row 1, column 3, and the box 1. So this is also valid. So we have to check for all the numbers that is present in the subgrid, each row and each column, right? Similarly, so we checked for this one 5 3 6 and 1, right? So we have to check in the similar way for all the rows, all for all the numbers that is present in the particular row, column, and the subgrid, right? So for this one, every number is present only once. Every number is present only once, and this empty cell, they have said it in the question, this empty cell, we don't have anything, right? So for this one we have to consider this one as dot basically, right? Dot, we have to ignore this dot, and we have to ignore this dot. So in this case, every number is present only once in the row column, particular row, particular column, and the 3 into 3 subgrid. When I say 3 into 3 subgrid, this one I'm speaking of. So this subgrid, this one, and this one. Same goes with this one. Same goes with this one, right? This one, this one. So yeah, so every number is present only once, and no number is this one. No repeating number is present in the same row, column, or the subgrid. So this particular board is said to be valid, right? So this particular Sudoku board is said to be valid. So in this case, we have to return true, right? In this case, we have to return true. If the valid board is not found, then we have to return false, right? So let's come to the second example here. So this one is same as example, except with the 5 in the top left corner. So yeah, 5 in the top left corner being modified to 8. See here, this is same as this one, example 1 they have said, but instead of 5 they have given 8 here. But here in this case, in every column, we should be having the different numbers. But see here, in the same column we are having 8 twice. Here in this case, this miserably fails, and in this case we have to return false. We have to return false, right? So I hope the question is completely clear. I hope the question part is completely clear. What we will be doing, mainly the approach is, we will be making use of the hash set, right? So we will be making use of the hash set. Why we will be making use of the hash set? We'll be making use of the hash set per row, per column, and also per 3 into 3 box to track the digits per 3 into 3, this one subgrids. So for this one, and per row, individual row, every row, and per each column we will be making use of the hash set to track the digits. Why we'll be making use of the hash set? Because we will check whether the number is present only once per row, per column, and per 3 into 3, this one, what do you call, box, right? So that is the reason we'll be making use of the hash set. So if any set already has that digit, then if any set, in the example 2, so just give me a second here. In the example 2, we already have this 8. When we check here, uh, we have one more 8 here. In this case, if any set has already if any set already has the digit, then we have to return false, right? So here 8 is present again. In this case, we will return false. So this is the approach that we will be going. Easy to understand, right? So this is the approach that we'll be going with. So what will be the time complexity and the space complexity, as we'll be going with the hash set per row, per column, as well as 3 into 3 box, right? So we'll be making use of the hash set. So what will be the time complexity here? So the time complexity would be big O of 81. So why the time complexity here will be by big O of 81? Because we are having the board that is fixed 9 into 9. So it is constant time per cell. So the time complexity would be quite obviously big O of 81. And what would be the space complexity? The space complexity would be big O of 81 as well. Why it is big O of 81? Again, we are storing at most 3 into 81 unique strings in the hash set. 3 into 81. Why it is 3 into 81 here? So 3 into 81 because per we are considering per row, per column, as well as per 3 into 3 box, right? So space complexity is big O of 81 because we are storing at most 3 into 81 unique strings in the hash set, right? So that is the reason space complexity will be big O of 81 for the code that we'll be writing in the future. So the time complexity and the space complexity for the code that we will be writing in the future as big O of 81. I hope this part is completely clear, right? So now we are completely familiar with the approach and this one, what do you call, the complexities, right? So as we are completely familiar, it's better to start writing the code now. Let's start writing the code. So first thing, what we'll do, as we have discussed, we'll be making use of the hash sets, right? Right. To store the scene digits for rows, columns, and the boxes. Let's create the hash set now. So this will be hash set. So this will be string here, scene new hash set. So this is fine. And after creating the hash set, we have to loop through each cell in the 9 into 9 board. We have to go with the two for loops here, right? For the row and column. So here I'll just give I equals 0, I less than 9, as we have 9 cells, row and column, 9 into 9 board, right? So here same thing goes with for the column as well. First I equals 0, I less than 9 for this one, what do you call, rows. For the column, so let's consider j here. For j equals 0, j less than 9, j plus plus. So I hope this is clear. So the next part within the for loop, what we'll be doing, we have to consider the current cell. Current cell means first we'll start from 0 comma 0, right? So I'll just go with char num is the variable name I'll be considering. This will be board of I and j. I hope this is clear. The next step is, if we are validating only the filled cells, means here they have clearly mentioned in the question. I have explained you while explaining the question as well, this one. So if this is empty, we will be considering this one as dot, and we will ignore this dot. We are not validating this one, only the cell which has the value, numerical value, only for that one we will be validating, right? For that also we need to consider that edge case as well. Here in this case, we are validating only valid this one filled cells. So we have to ignore the empty ones, right? So here in this case, if num not equal to dot, means here this one is empty cells. This one I have said this one empty, I mean multiple times, don't get confused. Within the if condition, we have to create the unique keys for row, columns and the box. Row means per each row, each column, and each box means 3 into 3 subgrid, right? So here for row, I'll just go with string row key equals, so this will be row will concatenate I plus this will be num. I hope this is clear. So let me copy this one twice and make the necessary changes. So this one will be, instead of row key, this will be column key, and this one it will be box key. Nothing but the 3 into 3 subgrid. Yeah, this one will be, instead of the row, this will be column, and this will be box. So this remains same. Actually, instead of I, this will be j plus them, right? Sorry. So this one has to be, as we are considering this one, what do you call, 3 into 3 subgrid or the box. So this one we have to consider I by 3 plus j by 3 plus num, because we are considering the 3 into 3 subgrid here. So that is the reason. So we have successfully created the unique keys for row, columns and box, right? So the next step after this one, if any of the keys is all if any of the keys already exist, then it is said to be invalid board. Means here, if scene dot contains of row key, so or scene dot contains of column key, or scene dot contains of this one, what do we call, of box key, then what we will do, we have to return false in this case. So what we are doing here, why we have written false, if any of the keys already exist, key should not exist again, right? When I say if any of the keys exist, means particular number exists in the same row or column or the subgrid, then it is said to be false. We have discussed this one multiple times, right? So if any of the keys already exist, then it is said to be invalid board, and we have to return false in that case. So otherwise, if it is not, if the key doesn't exist again, then we have to store them in the set. For storing them, I'll be making use of the add property. We have the add property that the hash set provides, right? So I'll just go with scene.add of row key here. So let me copy the same thing and make the necessary changes here. So here, instead of row, let me give column. This one will be box key, right? I hope this is clear. So let me come to the final part here. So if no conflicts is found, means if the element is not uh, the same element is not present in any row, column, or the subgrid, then the board is said to be valid, and in that case we have to return true, right? So let's return true here in this case. So this is it for the code, simple, right? So let me format the code once and let me hit the run button. So here we have the compiler error, bad operand types for binary operator. So line number 9, right? So what's the problem? So here bad operand types of binary operator. This one, yeah, I think let me try this one with single inverted comma rather than double inverted comma here. So this should be char, right? Not the string. So let me give this one with a single inverted comma. Let me run this one. So yeah, now you can clearly see. So this was the problem. We have to make use of this one single inverted comma here, not the double inverted comma. So you can clearly see here the sample test cases are getting passed. So let me hit the submit button now. I hope this works. Let's see. So here we are getting the wrong answer, right? So let's see what is wrong here. So let's check what is wrong here. So here, let me minimize this one. Mm, yeah, here on the line number 12, um, we don't have to use I. This is I by 3, right? Plus j by 3, as we are making use of the 3 into 3 subgrid, right? So we are just checking for the 3 into 3 subgrid. So this is fine. So yeah, let me run this one again. And now we are getting accepted still. Let me hit the submit button. Let's see whether this works for all the test cases or not. So yeah, you can clearly see. So that was the mistake basically. So now all the test cases are getting passed, right? So the code works absolutely correct in this case. So what we did initially, we discussed the question. As per the question, we discussed the approach as well as the complexities, and then we wrote the code and then submitted the code. The code works absolutely correct here. So all the test cases are getting passed here, right? So the code works absolutely correct. I hope the solution part is completely clear. For now, this is it. Thanks for watching, guys.